Hey everybody, we're live, and I want to really thank Matthias Bergstrom of Internet of Things, lead project architect. I want to really thank Matthias Bergstrom of Internet of Things, lead project architect. I want to, and so nice I had to say it twice, and I was actually about to say it a third time through my echo system. We are the height of tech. You're in Las Vegas. I'm in suburban Atlanta, Georgia. And in the spirit of Internet of Things, here we are. First of all, how is CES let me get this little bit of I can't resist the news. Tell us how CES is in this unusual situation we're in.
Well, it's hard to say yet. I mean, setting up the booths, doing the normal stuff, making sure the floor show is ready, up and running. It looks the same as every year. There is no real difference, right? So I think everybody is just nervous about that the attendance numbers will be really low. And that's, I think, is a bit of a nervosity that goes through all the exhibitors. But the work right now, which is setting up and preparing, is moving the same way as every year. So right now, not a lot of difference, right? That's talk to me in 2 days and I'll tell you. But right now, pretty much as always.
And in fact, I'd like to say it would be great to do this more than once this week, but Internet of Everything is really a truism as demonstrated by how we're communicating, but also the systems that you all have set up and with your company's based around. Talk about what the Internet of Everything is about, or IoT Corp.
Well, so, I mean, in the basis, it comes from the idea, not the idea, but the need that if you're going to make a smart city, you're going to have millions of sensors, right? I mean, we're talking huge amounts. So we're not like just a smart hospital is going to need hundreds of thousands of sensors. And when we started building on these systems, we realized one problem, and that was the major problem. The platforms that exist will not verify if the sensors are giving you validated data or just data. So let me explain that a bit better. Sensors break, and they just don't go from 1 to 0. They break by starting giving you erroneous data. They will give you wrong quality of the air. They will give you the wrong sensoring data of doors being open or not because there's oil on the sensor or whatever. The point is that erroneous data that comes in over these sensors are then fed into AIs that then makes decisions that goes to the actuators, right? And these steps became nearly impossible to monitor and handle because there is no platform that does that. So when we started on the work of building the Internet of Everything, it came down to one thing. How can we validate the data delivered and going to be used to make sure that no malicious are injecting bad data, but at the same time, just validating the data towards sensors that break, right? I mean, if you trust your traffic routing in the city to sensors and they start giving erroneous data, it can create, people can die, right? So that's where we started. So the design of the whole hosting platform, which Internet of Everything is, started from the simple thinking of how can we make sure that we can validate the data. So we did that validation based on 2 different ways. We use a blockchain where all the checksums of the data goes in. And then we use a small AI that does a deviation verification. So to make sure that the data is not deviating according to a norm, right? And very similar to how a fraud detection system on credit cards work in reality. So it's a very tested and old technology today. I mean, it's been credit card companies been using it for 20 years, right? It's the same thing. You're looking for deviations that are not explainable. And as these deviations happen, we can ignore or say we don't trust that data. We need somebody to go and have a look at that. But we then, over our system, built it as a peer-to-peer so we can have a self-healing function. So one node can give over the responsibility to another node. And that's the basis of why it was built. Then, of course, comes in a lot of things. How do you make decentralized peer-to-peer systems? How do you control them? How do you service manage such systems? So we had to build a whole rules and logic concept that doesn't exist today, which is really about how you can administrate services on a decentralized platform and still keep security. Because that's, of course, a huge problem in a decentralized system. Somebody hooks in a malicious node and he can start taking over the system. To protect that, we also used the blockchain. So you have to verify your node over the blockchain, and that way you have a traceable, let's say, less trusted model, right? You can trust in a trustless world. You create that model through a consensus algorithm compared to just trying to set it up with a certificate model or some other kind of encryption model. You also have to fall back to a trustless system. So I would say that's the basis of the platform. The platform uses still, just like other platforms, we use a containerized system. So you build your whatever service you want to deploy, you build it in a Linux container, you deploy it just like it's a Kubernetes or whatever it is. The difference is it runs on a decentralized platform that can be then installed in many, many different scenarios. The scenarios we are working on right now is everything from smart or informed infrastructure, which means we predict potholes before they happen. That's not the service we don't always build. We provide the platform to run the service, right? But we really think it's cool to be able to predict potholes, right? But that's another story. We work with water and what's called storm drains to predict how that works and to make sure that the storm drains are not clogged when there comes a flash flood, and all of these kind of things to make society run better, right? Because this is not so much, the Internet of Everything is not so much about consumer products. It's much more about the stuff we don't see, the things that happen underneath what we see, right? We want the service layer to work. To get the service layer to work, we need the infrastructure to be informed to make sure that everything is running smoothly. I think that sums up. There's, of course, a lot of nifty and efficient features with this. It's cheaper than running. As you're running on a localized peer-to-peer network, it's cheaper than sending data to the cloud and then back again. It's cheaper. It has benefits from a sustainability point of view. It uses less power than going into a data center like a server farm, because the heat dispersion is different when you spread out the different compute systems. So there's a lot of benefits when we use sustainable computing. So we do a power balancing between the different devices in the cluster, the peer-to-peer cluster, to make sure that we are not wasting any power or, through heat, right? So there are a lot of different customers and usages for this platform. And right now I would say that the sustainability factor, sustainable computing, in combination with this verified data model, that's really where our customers are really been very excited about the platform.
I'm curious.
It's a long answer. It was a long answer.
No, it's a great answer, but it also makes me think of a problem that's plaguing many American cities, and actually I would dare say cities around the world in the middle of the pandemic, and that's the uptick in crime. Can your service be tailored to help, say, the Oakland, California police force predetermine where officers should be deployed, based on crime activity?
So you can do a lot of things on that. We looked at that together with Port Authority in New York. We haven't done anything. It was just a preliminary thinking, right? but it's about predicting where you should have resources deployed. That's really what we are talking about. And that can be done in multiple different ways. The question is, how can you do it sustainable? Because if you build a system that's going to trust, so I'll take an example, which is quite a funny example. So let's say I build an AI for traffic routing, and I put it up for running on a cloud system where I'm paying for, and we should remember, on a cloud system, I pay for bandwidth, I pay for storage, and I pay for computing, right? So I'm paying for three things to get one answer, whatever that is. And you build this perfectly running traffic routing system that has models for, cars come this way, trucks do this, blah, 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 blah. And then comes the 4th of July. That AI is going to go completely berserk. He doesn't have a clue what's going on. Why are people walking on the streets, right? The cost of, so this system was running in a city in the US, I cannot say which one, but the interesting thing is that the cost of the 4th of July broke their budget because the AI ran out of control at the cloud provider and just pumped. He tried to calculate the solution to this. He couldn't understand where were the cars, why were there people there, what's going on, right? So all of a sudden, the whole system, they killed the budget of that city completely just for, I think it took 12 hours for the AI to consume so much cost, right? Well, by computing power, right? So it was quite interesting effect. So sustainability is not just about power consumption, it's also about that we need to control the costs. And cities especially have budgets that needs to be under control, right? I mean, we're the taxpayers, we're paying for it. We don't want it to be out of control. The problem is there is no limits on cloud services, right? I mean, AWS is not going to say, oh, right, no, we're going to give you this for free because you now paid this much. No, if your system runs rampant, you're just going to have to pay for it. And AI has a problem. Well, it's not the problem, it's how AI works. It can only work if it got the right data, right? If you're going to give it something else, it's just going to run rampage and it's going to cost you.
Yeah, garbage in, garbage out.
That's how it is. And so, yeah, it's not even just garbage out because you never really get to garbage out. You get garbage in, high costs, and nothing out. Basically, the AI can't solve it, so you don't even get anything, right? Well, the thing you get is a huge bill. So like, here's 30 million, which was the cost for the 4th of July. So I'm just saying that platforms that handle these things, validate data, verifies data, before it goes into any kind of custom compute system is also something to consider when you come to sustainability, because you can't install a smart city that you can't pay for. I mean, that would make sense. So that same thing I would say to Open Police, it's not about just figuring out where we should allocate least resources and stuff. It's how do I do it sustainable? How do I make this so this is something that we can trust for years and years and years? And that's where our system also comes into play, right?
How many
Does that make sense?
Oh, absolutely, yeah. How many years out are we before we see a city that is absolutely controllable from its center? You can control various types of resources.
So I don't really want a city that's controlled from its center. I'm for decentralization, so I'm not really for any kind of centralized solutions. Centralized solutions creates too many risk factors. It opens up for attacks. It's a very dangerous. That's why the internet was never designed to be centralized. The World Wide Web is centralized, and people confuse the World Wide Web with the internet at many points. But the internet itself is decentralized. Sometimes I hear the Web3 people talk about, oh, we're going to make a decentralized internet, and I go like, no, the internet is decentralized, right? The web is not decentralized. Two completely different things, right? The internet is the carrier.
From the standpoint of
go ahead.
From the standpoint of a guy who served as an aide to the mayor of Oakland about a decade ago plus, the constituent at the end of the day is going to say it was your fault that something didn't go wrong, right? So we have to at least have some illusion of control.
Oh, but you can control decentralized systems, right? The internet is still controlled, but it's controlled in a decentralized service management, which in the internet is the border gateway protocol. We don't have to go into that, but the point is we have a similar kind of system as the border gateway protocol, which we call a service manifest, right? It's a manifest that goes out on the peer-to-peer network. It explains how it should, it contains all the rules, the policies, and the logic of the service. And that way the service can be controlled even though it's decentralized. So it doesn't need a centralized point. It doesn't need it, right? Just like the internet doesn't need it, it doesn't need it. And I think that's a huge benefit, because the risks of running centralized systems for smart cities is lag, right? So we talked about the dangers of validated data, but lag is another huge problem. That, you know, when you're talking millions of sensors and actuators and all of a sudden it's starting to be laggy, it's dangerous. Basically, this is dangerous. This is not like when you're opening a web page on the internet and it's a bit slow, right? Or on the web. Sorry, that was my fault. I even did everything. But, you know, and that doesn't really matter. But if you're going to be traffic routing, lag really matters, right? So there are that. So I would say that to build a fully sustainable, smart infrastructure for a city today, where I would start with on the infrastructure itself, I would say we are 2 or 3 years out to create a city that has the other parts of it. And I would lay this into 3 layers. We have the informed infrastructure, right? Which is making sure the city runs as it should, right? Then we have, let's call it a controlling layer, where we have everything that's interactive, everything from shops in reality to, well, anything where you can do things. And the last one is the citizen itself, where we come to e-governance and teaching and all of these things. So it's these 3 layers, right? And I think that we are going to see layer 1 and layer 3 before we see layer 2. I don't think shops and stuff are going to be interactive with the city at an initial part. And they don't have to, because they're going to be on their own websites. They're going to be on their own things. They don't really need to be integrated into the city, because they have their own powers to work with, right? Mm-hmm. So it's really about informed infrastructure and informed citizens. And I think that these things are, I don't know, 3 to 5 years out, I would say. I don't think it can be done now, out of the simple reason that we can't really trust it. I mean, putting in the millions of sensors, as I said, how are you going to trust it? Yeah. That's a dangerous idea, going like, let's put in 5 million sensors and now I'm going to trust that they're all working 10 years from now, or even 5 years from now, or even next month, right? I mean, it's a dangerous idea. And as I said, the risk is also that you're sending all this into a cloud system, and then the AI gets confused, he goes rampage, and you're just paying, you know, the cloud provider millions and millions for nothing. That's another, you know, so there are multiple layers to consider to be able to do this. I would start very simple. If I was a city, I would say, okay, I'm losing lots of money on potholes. Let's see if we can predict potholes and how much that would cost me, right? Super service for the citizens. Really a good way to use smart infrastructure or smart city, right? I'm making my city smart. We are going to take away potholes. That would be amazing, right? And next one would be, okay, we're going to use smart systems to make sure that the water and power works, right? We're going to do the same thing. We're going to make sure we have informed systems for power and water. And we're going to make sure that works, right? Or storm drains, or, you know, everything that can create the problem. Doing that is nothing you just put on an app for your citizens, but you have a huge gain for the citizen, right? I mean, you can tell them, right? We are doing this for you. We are going to have no potholes. What other city don't have potholes? And I think these kind of things is, there's a bit too much fluff when it comes to smart cities. You probably know that you work for Oakland, right?
Yeah,
So,
and you'll bring it right to the phone to the citizen. You bring it to the citizen's palm, basically. But
yeah.
you're absolutely right. How do people at, for example, the city of Oakland find out about it? Your website.
So yes, our website, which is ioecorp.com, and we do go around to different kind of conferences when it comes to cities. And I am, to tell you the truth, which is going to be quite funny, going to release an open letter to the cities of the US about how smart and informed infrastructure can lower cost and make the lives of their citizens better. Not smart cities, it's up here. Smart city is like when you have all these three layers, right? I'm just talking about the informed infrastructure layer, the part which you don't really see, but it's really nice when it works.
Yeah, it's almost
It's
like
where this.
it sounds like the digital version of the utility or concept, which is really not a concept. It's actually an operational function in Disneyland, Disney World, where all the infrastructure is underground, and you can go from, say, Tomorrowland to Fantasyland underground if you're performing, and never see above ground, and all of the stuff and all the infrastructures at the bottom, how the city works. But this is the cyber version of that, right?
Yeah, this is what we need, right? We need to understand that it's not about the apps. The apps comes later. It's about getting the AI and the information to become, let's put it this way, we want the data to become information. We want to refine. We're getting a lot of data, right? We want to refine this data into information, and that information we want to use to do predictions. That's really the process, right?
Yep.
So we want to refine things, right? And then finally use an AI to do predictions on it. And that's somewhere where we need to start. So a lot of these smart city projects I have seen and been involved with, they start in a very strange place. They start with going like, okay, so how can we talk to the citizen? How can we tell him things? How can we like do nice flashy apps, right? And then they spend the whole budget on doing graphics. And then you sit there and go, what's the point, right? Nobody got any happier from this except maybe the guy who made some graphics. But the point is that cities have problems, and smart technology together with AI can solve those problems. The thing is, most politicians and most cities are not looking at it that way, right? They are looking at it like that's a different thing. That's a different thing all the time. Well, they think of smart as like we want the city brain or something, right? I don't want a city brain. I want my water pipes to always work, right? I want the streets to be perfect. I want, the electricity to work and be as cheap as possible, right? So I have, as a citizen, I think I can talk as a customer of such a system because that's what I want. I think I want the same as every other citizen, right? We want it to work. And that's what the informed infrastructure can do for us. Then you can lay other services on top of that and just do more things, right? But it has to start with an informed infrastructure. And I believe that informed infrastructure, I think 3 to 5 years we could have that. It would lower costs for all cities. I mean, we're talking water leaks in America could be reduced because we can predict pipes before they break, right? We can change the pipes before they break, right? And in the US today, we lose about $6 billion a year on water leaks, which is quite insane if you think about it, right? And potholes is crazy expensive. I mean, we are talking with the damage on cars, damage on trucks. Of course, fixing the potholes is not as expensive as the problem that they show up, they're not reported in time, and you get damages before they are able to fix them. So there's huge costs in these things that we can reduce to nearly nothing. Yes, it's never going to be possible to reduce something to completely zero. It's not going to happen because there's too much factors involved. But we can reduce this like enormously with informed infrastructure. And I think that's the next step we are going to be seeing when it comes to smart, is that people are going to start becoming smart about smart. It was a pun. I know it's a bad pun, but I only have bad puns.
Hey,
it's like, sorry about that.
No. Your booth number for those who may be at CES or seeing this right now.
Oh, so we are in 609. Wait, now I get, 60970.
60970. That's where they are, folks. Booth 6097. Oh, I said 979. You said 970, right? Let's try that again.
970, yeah.
Yeah, because as CES denizens know, there's a big difference between a 9 and a 0.
Oh, yeah. It can be in the completely different, different place, right?
You can literally chase your own tail trying to figure it out. I don't know. So there we go.
Oh, well.
And hey, you know
Everyone
what?
Walks around here going like, where?
When you go to the booth, we have to schedule a time so you can show us what the booth looks like from here.
Absolutely, man. That'd be great.
Yeah, definitely.
Oh yeah, I can demonstrate. So we have another fun feature, which
yes.
I mean, I call them fun features. Most people would probably call them revolutionary, but we have a way where we detect all kinds of malware, isolates the malware, and reduces the malware to nothing. Not as you usually do it through an algorithm that detects you have a bad kind of code in your system. No, we detect that it's behaving strangely on the network. We use the same kind of AI that detects deviation, like the credit card fraud, and we look at different processes that are running inside of this cluster of machines, right? And we go like, hey, that machine is not, there's something wrong here, right? So we detect that deviation, and then we go in and we look at the processes on that machine, detect the process that is behaving strangely. Not, we're not looking for malware. We have no malware detection programs, whatever that is. Instead, we just look for the process that is trying to, I don't know, connect the server in China, right? We go like, yeah, that's not okay because we don't have any services there. So because we can also check on the service manifest, right? We can check the rules, and if the rule says, okay, this service does only exist in Oakland, and of course, if somebody's trying to ping China, we go like, yeah, something's wrong here, right? Because that machine should not be doing that. So we can isolate that process and remove it. And this is, interestingly enough, a more secure way. Well, that's not true. Sorry, it's a wrong way to put it. This is a faster way to detect a badly behaving node, right? So if you have a node that gets infected, if you use an anti-malware software, it will take you a certain amount of time before you detect it. When you use a network behavior, you detect it instantly.
If I may, you're spotting a virus.
Yes.
Yeah, I thought that might be appropriate.
Yeah. So we are demonstrating that in the booth anyway. So we can inject a bunch of different real-world malware, which is dangerous, but it's on its own sandbox, right? But we inject real-world malware into a running smart city simulation and show how the nodes detect this malware and isolate it. So it's a real-world setup, even though it's a simulation. So that's a pretty cool demo.
Yeah, you have to show that to us. You have to set up a time.
Oh,
and
yeah.
folks,
That'd be great.
Yeah, folks, check them out there in Eureka Park. Fun place with actually a great cafeteria, which I miss. And they have a great Asian bowl there. Or you can do the jalapenos and stuff if you want to, but that I digress. Hey, stick around in the backstage. Folks, we're going to be back at CES with this man later. We're going to talk backstage. Subscribe to Zennie62, bookmark oaklandnewsnow.com, and for more from CES 2022. Hey, stick around the backstage. Matthias, don't go anywhere. That is this broadcast.
I'll be here.